Here's an overview of the method that we're going to use to analyze available soil phosphorus. First, we extract or shake the soil in the sodium bicarbonate solution, which is also called Olsen solution. Then, we're going to allow that solution to settle for 10 minutes so that some of the clays settle out to prepare it for filtration. Then we filter the solution. There are two methods for that, and that gets rid of the rest of the clays in the solution, making it a clear solution. Then we neutralize this filtered solution with sodium bisulfate, which reduces its pH and will cause all the bubbles from the bicarbonate to leave. And then we will react that neutralized solution with a reagent package, which will create a blue color in the solution, which we then read using a colorimeter. So we read the blue color value with a colorimeter, and depending on how intense that blue is, we are then able to calculate the available soil phosphorus in the original soil sample. That's the overview, and now we'll see it in detail. The first step in the procedure is to weigh out 2.5 grams of soil, which can be either field moist or more usually air-dried soil. Then 25 milliliters of Olsen extraction solution are added to the soil. Olsen solution is sodium bicarbonate in water, adjusted to a slightly basic pH with sodium hydroxide. The soil and Olsen solution are shaken for 10 minutes. Then the soil suspension is allowed to settle for 7 to 10 minutes. This time should be long enough to allow efficient filtering in the next step. There are different ways to filter the suspension that are shown in this video: using a filter press, using a traditional filter folded into a funnel, and using a vacuum pump made from a car tire air compressor. This picture shows a simple filter press that can be built to allow quicker filtering of the soil extracts. To use the filter bottle, a circle of filter paper is cut to fit inside the lid of the bottle. The lid also has small holes punched or drilled into it. Between 10 and 15 milliliters of soil suspension are placed in the filter bottle and then pressed so that filtered solution is pushed through. To filter the suspension in a traditional way with filter funnels, a 90 mm or larger filter circle is folded carefully into a funnel. The soil suspension is then transferred to the funnel. If many samples are filtered at the same time in this way, the filtration should be started and stopped in the same order of samples, since the Olsen solution will continue to extract available phosphorus during the longer filtering process, and the additional time should be standardized. The extract can also be filtered quite quickly using vacuum filtration with a rig like that shown here that is made using a modified car tire air compressor. The filtered extract has a high or basic pH and must be neutralized using acidic sodium bisulfate or other acid before analyzing. Add the 7 milliliters of extract to the 3.25 milliliters of sodium bisulfate solution in the cup. The neutral extract is then diluted to 20 milliliters volume before analyzing. As this is done, the cup is also rinsed out using small amounts of distilled water. The extract and diluting water need to be well mixed before analyzing. While the solution finishes bubbling in the cup or the cylinder, a vial can be prepared with the contents of a reagent pack for the phosphate analysis. This is the HANA low-range phosphate reagent pack. See the toolkit manual at the website for details. Add 10 milliliters of diluted extract to the vial with the reagent. Cap and shake well. The vial should be opened slightly to vent it several times, since some bubbles will be released. If the bubbling is very vigorous, it may be necessary to add slightly more acid or bisulfate to neutralize the extract for this soil, since the color development depends on low pH in the extract. The remaining solution is put into a second vial to act as a control for the colorimeter reading. Since there are a number of steps in this process, we'll review them here quickly with sped-up video in about 1 minute. After color develops for about 10 to 15 minutes, the vials can be read using the HANA high-range phosphate colorimeter and the procedures shown here. To close this video, we show the steps for calculating and interpreting the results for available phosphorus in soils using this test.